So this is 4.2 of our June 2023 past paper that we just wrote recently, right? That you guys wrote. Why am I saying I also wrote it? I didn't write it. So yeah, please do share with me other provinces. This is a Gauteng paper. If you did a Northwest paper or a KZN paper, Eastern Cape or Limpopo, Northern Cape, Western Cape, all the provinces, even Mpumalanga, right? Or Free State, please do share with me those papers. I will do them. I will literally do them if all the time in the world. Well, not all the time in the world, but yes, I will do them and post them for you guys. Anyways, thank you so much. Let's do 4.2. We are given an exponential function here, right? F of x is equals to 1 over 3 all to the power of x. And in this 4.2.1, we're asked to write down the asymptote of f. So an exponential function has only one asymptote, and that is a horizontal asymptote, right? Which in this case, we have f of x being equals to 1 over 3, right, to the power of x. So the asymptote here is y is equals to 0. Why? Because the standard form of an exponential function, it only has one asymptote, and which is this one here, right? Q. My q in this case is equal to 0, right? So that is the asymptote of this specific question. So now let's go down to 4.2.2, right? We are asked to find the inverse of this function. So we have f of x is equals to 1 over 3 to the power of x, right? Where there's just f of x, we're going to write y is equals to 1 over 3 to the power of x. And then we swap, right? Where there's x, you put y. Where there's y, you put x, right? Hope you got that. So here it's going to be x into 1 over 3 to the power of y. And then now we're just going to write this in log form. Remember, log, the same as log, our base is a and this is b, right? So in this case, y is equals to my log of base 1 over 3 and x. So this is going to be the inverse equation for this function here. So let's be done with that. So let's go down to 4.2.3, right? So 4.2.3, we're asked to sketch the inverse. So I'm just going to sketch it in this given axes, right? So if this here it's 0 and 1, then for the inverse, it's going to be somewhere here. Let me just put it here into 1 and 0, right? And the inverse of this equation that we found in 4.2.2 is going to look something like this. It's going to look like this. So yeah, this is the inverse of f, right? That's how we draw it. What's important is this coordinate form here of 1 and 0 that you need to indicate to get your 2 marks. So 1 mark for that point and 1 mark for the shape. Let's go to 4.2.3. 4.2.3, we just did it, right? We drew it. 4.2.4, we are asked to write down the asymptote of the inverse. So the inverse, remember the equation of an inverse that we found in the previous question, it's log of base 1 over 3 x, right? And now to find the asymptote of this one here, it's equals to log of base 1 over 3 x plus 3. Remember, a normal exponential function which has y is equals to a b to the power of x plus q has an asymptote which is q, right? We normally say it's y is equals to whatever value of asymptote, right? In this case, because it's an inverse of this, its asymptote is going to be the value of x. Please don't get confused. Why? Because when you draw, let me just rub this. When you draw the inverse, as I did in previous question, I drew it like this, right? So it's not touching these x-axes. And our asymptote runs through this, right? For the previous graph, so our asymptote was equals to 0, but now because we have made a horizontal shift which shifts to the left, our asymptote is going to be somewhere here, which is x equals to minus 3, right? So the graph will run something like this, going down like that, right? Because of this shift. So in this case, the asymptote is just going to be, oh, why did I say 3, guys? I said 3 here instead of 2. Anyways, so our asymptote is going to be equals to -2, right? So that is the asymptote of this question here. Anyways, let's continue now. Let's go to 4.2.5, which is really, it's not difficult. It looks difficult, but it's not. I hope you guys nailed it. Hope you nailed it. It's really not difficult. So what you're asked here is to prove that f of x all squared minus f of minus x all squared is equal to f of 2x minus f of minus 2x. So really not difficult. So let's look at the left hand side. Left hand side, we are having f of x all squared minus f of minus x all squared. Let's write it down. In terms of what's f of x is 1 over 3 to the power of x, right? So it's 1 over 3 all to the power of x into squared minus 1 over 3 all to the power of minus x. Remember, this is negative squared, right? So to write this down, you can say 1 over 3 all to the power. So these two will multiply this x here is going to be 2x minus 1 over 3 to the power of minus 2x. And then we can just take this 3 up. We have 3 to the power of minus 1 all to the power of 2x minus 3 to the power of minus 1 all to the power of minus 2x. So to write it properly, you're going to say 3 to the power of minus 2x, because this 2 will multiply this, and minus 3 to the power of 2x. So this is the left hand side. Now let's do the right hand side. Let me erase this quickly. I'm not going to erase the bottom so that we prove that it's actually equal. So let's do the right hand side. So the right hand side is f of 2x minus f of minus 2x, right, equals to, so my f, it's 1 over 3 to the power of 2x minus 1 over 3 to the power of minus 2x, right? So it's just going to say 3 to the power of minus 1 to the power of 2x minus 3 to the power of minus 1 to the power of minus 2x. So it's equals to 3 to the power of minus 2x minus 3 to the power of 2x. So if you can see this here, it's the same as this. So they're the same. So therefore the left hand side is equals to the right hand side. So we are done solving 4.2.5. Thank you so much for watching. Let's now solve this question here, question 5. But I'm going to do it on another video. Please check it out now. Thank you so much for watching.